Okay, I repeat back the just now the partially confounding. We get the sum of square for A, B, C, and BC, and so on. So I have shown it to you how to get the sum of square for ABC number 2. You get the sum of square for AB, get from the observation number 1, and then the sum of the AB. Okay, the sum of square for the A we get from the here. I have shown it to you. The value is negative 817 square divided. Then you can get your sum of square under the A. Okay, so this one I have shown it to you. So just now I mentioned to you the blocks. So to get the sum of square for block, because we have two confounding factors here. The factor ABC you are confounding in the block 1. The AB you confounding in the block 2. Okay, so you do the confounding of these two. The block 1, here the replicate 1, ABC will confounded. For the replicate 2, the AB will confounded. So if you want to get the sum of square for the block, we will do the total out for the confounding from the first one and the confounding on the second one. Okay, then we will get your sum of square for the block. So therefore, the sum of square for the block will be get from the sum of first sum of square for the ABC under the replicate 1. The sum of square, just do the plus minus sign of the here from the first ABC, and then you get the SSAB get from the second replicate. Then you just get the total. Then this one is a 458.125. So this one is what you have in your sum of square for the block, 458.125. Okay, so you can check it carefully about the sum of square here, where I put the SSABC number 1 means that is using the observation for number 1. Okay, if the SS for the AB number 2 is means that they're using the observation for number 2. Okay, this one is how do you get your sum of square for block. You can be check it out. I think the after the class you can be take it out, then you just check it out again. Okay, so that you need to click clear. This one is get from the first observation. This one is get from the the first replicate. This one is get from the second replicate, and then you total out it. You will get your sum of square. Okay. So I will upload this one later. So we go back to the just now what we have. So under the fractional just now I have mentioned to you all. Okay, so means that if we have a treatment combination here of all the 8 treatment combination, so we only run the first half or the second half. So it depends on what is a generator you consider. So because we use the ABC as a generator, so we will run all the plus here, or we run all the negative here. So we either run this treatment combination, we will expect that if you're using only these 4 treatment combination or these 4 treatment combination, we can be estimate out those of the important factors through these 4 treatment combination only. Okay. Before you can be know all these things, let us go through the here. The I just now I mentioned to you is a the I here is a defining relation is equal to AB is plus, or you can have a negative. Okay, I think we stop at here. So the defining relation is equal to I is equal to ABC. Okay, we will put the I will be equal to the ABC here. So later on, we will use this information here to get the effect of each one will be combined together. Okay, but before that, before we do or for get the relationship of this thing, we will let us see the plus minus sign first. Then from the plus minus sign later on, you need to know how to calculate the effects itself. Okay. So here, from the plus minus sign of the table, we may estimate the mean effect of the A, B, C, and as follows. So how to calculate the factor of the effect of the A? You are using the contrast divided by total average of them. Okay, so the effect of the factor A here, if you refer back what you have here, if I only run for the, okay, now I only concentrate on the plus sign here. Okay, so if I want to know the effect of the A, so the A only you run 4 of them. Therefore, the factor A, you want to calculate their contrast will be equal to plus A minus a B minus a C and then plus a ABC because you only run one half of them. If you want to calculate the contrast of the B, what you have is a negative A plus B minus C and then plus ABC. So these are the 4 of them you can get their contrast. You just forget about it, the bottom here, because you only run the first one half of them. Okay, so I will write it here. If you want to calculate the effect of the A here, we do not write the effect directly. We will use a short form. I mean the different notation from the previous chapter here. We will put the bracket here, A. Okay, the square bracket here, A, is referred to the effect of A, will be equal to the, we use a notation as a LA. Okay, the effect of A will be just the contrast of the A here, where you have a A minus by B minus a C plus a ABC divided by the 2. Okay, so this one is the effect of the here because you only use a 4 treatment combination. You only run the fraction of them, one half of them. Therefore, you only use a 4 of them. You just take the average of here. The effect of B also the same thing. You refer to here just now the table. You have a LB. I use the notation LB. It just depends on the plus minus sign of the B here. You get your minus A plus B minus C plus the ABC divided by 2 also. Okay, so all this sign is a minus sign and the plus here. I will refer to the here. Okay, the B here is a minus A minus C, then plus B plus ABC. So the C one, you have a 2 minus 2 plus. 2 minus is minus AB plus a C plus a ABC. So therefore, I have a factor C will be equal to the, is a minus A minus B plus a C plus a ABC. Okay, get the 2 here. So this one is the effects if you only use 4 of them, just the one half of the treatment combination, then you can calculate the effect of the A. It's not really from the effect of A. If you really want to calculate effect of A, you must have considered all. Okay, you should be considered all of the treatment combination, then you can calculate the effect A. But now you only run part of them, one half of them. So therefore, I will put the bracket here to indicate that we just use only 4 information, 4 pieces of treatment combination to calculate the effect of the A here. So similarly, if you want to calculate the estimate the 2-factor iteration effect, so we can have a, okay, the BC here, we can calculate the BC well from the above here. I just show you here. From the above here, for the BC here, it's just a minus A and the plus A and the plus ABC. The rest of them is a minus B minus C. Okay, so I can list it down here. You will have the here, it will be the A minus B minus C. So similarly, you have a BC, you have also the 2-factor is the AC. You have a LAC. Because why I put the LAC and then the bracket here, because different textbook, they use the different notation. So I just let you know some of the textbook, they use the L, some of the textbook, they use the square bracket here, the square bracket here. Okay, so you have a And then finally,
Doctor,
yeah.
sorry, why divide by 2?
Why you still remember what is your contrast previously? Your contrast, you have n times 2 power of k minus 1. You see from here. You hear. Why you do this thing? Why you divided by 2 here? Because you can see here, you take the average value of these two, and then the average value of these two. Okay, or you, because I show you we have a two different proving techniques. You get the you divided by n because you have n observation. Then after that you total out both, you take the average. So this one is why the 2 is come from. Okay, your n is for this case is n is equal to 1. We still studying the n only single observation. Do you get it?
Okay, so that means for this case, my n is 1 lah.
Yeah, we only
Oh,
study
okay,
the
okay.
n is equal to 1 first. Okay.
Yep, okay, can. Thank you.
Yeah, yeah. So the AB will be equal to L for the AB. Okay, they will equal to the minus A. Okay, so this one is for the two-factor iteration. This one is for the main effect. If the main effect, this one is a two-factor iteration effect. Okay, but they are not the complete effects yet. Okay, those, if you observe the effect of here, if the A, you will use this one is A minus B minus C plus ABC divided 2. So if you observe it, this one, they actually will be similar. You can see that this thing and this thing is actually the same. So in fact, the A and the BC is actually they are similar. Okay, after that, you see the B and the AC minus A plus B minus C plus ABC or 2. So these two will be similar. Okay, you can see that these two are similar. The last one will be here. Okay, if you observe that, you can see that calculating of effect is calculating of the effect for the C is similar to the effect of the AB. Okay, so this one will lead to the following notation. Okay, those actually what we have the for the A is actually is equal to the L for A will be equal to L for the BC. Actually, a calculating of these two. So, or sometimes they will put it as a L for the A. It's actually the effect of the A is actually consists of the A and the BC. Okay, because you can see calculation of the effect A and the calculation of the effect of BC, they are actually this both of them. Okay, or we can be put it as another notation of here. The A will equal to the BC. Okay, the LA is equal to LBC. Also, we can write as a bracket of A will equal to bracket of A, the AC. So, or some of them, they will put it, instead of putting the L, we can put the A will equal to the A plus BC. Okay, so we are using this style of the notation to represent here. So if you can observe it, you run only the one half of them, you calculating the effect of the A is actually similar to you calculating the BC. The B is will be AC. The C will be similar to the AB because as you observe the control same. B will equal to the L for the B will equal to the L for the AC. So we can write it as a LB. It's actually, they come from the B plus the AC. Okay, the effect is come from both of them. Okay, or of course we can be used here. will equal to the AC. Okay, so we call it as a B. It actually consists of the B plus the AC. Okay, then the last one is also the similar one, LC. Okay, so these are the thing is what we can observe just now from here. So therefore, you can see the key point here, what I mentioned. We cannot estimate the main effect and two-factor iteration separately because of the contrast there is here. So in this example, A and B, A and the BC, in fact, because we cannot estimate it separately, both of them are contrast the same. So therefore, there is another keywords here. We will say that A and the BC are aliases. Okay, we call them as aliases. And then the B and the AC are aliases because the B and the AC are aliases. And then the C and the AB are aliases. So in fact, we estimate the ABC. If we estimate the A or B or C, actually we are estimating the A plus BC. Actually, they are combined as estimate together. Okay, you are estimating the B is actually it combine the B plus the AC. Therefore, I say that. Okay, so when you calculate the effect of, actually you are not calculate really the effect from A. It's a effect from the A and the B together. We do not know how much is allocated for the A, how much is allocated for B, but they are together. So therefore, when you run the 1/2, you are not really calculating the effect of the A using this formula. You just calculate the effect of A, you alias with other factor together. Okay. So similarly for the last one, if you're calculating the effect of the C here, actually you are calculating is C plus AB. So this one is what we have called is a alias structure here. Okay, so you can see that A and the BC, B and the AC, C and the AB. If you observe the pattern here, you can see that if the A alias with BC, you can see the symbol here is A, B, C. If the B with the AC, you also get the A, B, C. The third one is a C with the AB. So you can see also there are ABC as well. So what we can get from this thing about the defining relation. Okay, just now we use the ABC as a generator so that we know which half of them we want to run, which one half of the treatment combination we want to run. And then from the ABC here, the generator here, we write as a defining relation, I equal to ABC. Then we will know which are the aliases. Okay, from the just now, if I list down all of these things, then you can observe A and the BC are aliases, B and the AC, C and the AB are aliases. Okay, but we do not want to all these things. We can get all the structural aliases from the following example. Okay, so I will show you how to get the alias structure without calculating the plus minus sign, without calculating the contrast. Okay, so I give you this one is one of the example. So let's say we have a defining relation is using the above one, I will equal to the ABC. Okay, the defining relation will be I equal to ABC. So we want we have a alias just now. We have A will be equal to BC. Then we have the second one, the B will equal to AC. Then the third one is C will equal to AB. Okay, based on the just now the example here. Okay, A will equal to the BC, B will equal to the AC, and then C equal to BC. So how we want to get if we use an alternative way to get the alliance structure. So what you need to do is just the I will equal to ABC. If you want to know what are the factor A alliance with the other factor, what you need to do is just multiply the A. Left hand side multiply A, right hand side multiply A. Okay. So this one you will get the A times I is you can look like it's an identity. So therefore you still get the A. Will be the A square here, the A square here, you will get the A square here and the BC. Okay, so I need to take the note here, the AI, okay, will equal to the A back. And then another one is a square. If as long as any factor square, you will get your I. So I is like the multiply identity. So therefore over here, you get the A will equal to BC. So from this part, from the generator and then defining relation here, then you can know that which are the two factors are alliances with each of the others. Okay. Similarly, for the I will equal to ABC. If I want to find the B, so I have a BI will equal to the A, B, C, B. So from here, I will get the B will equal to AC. Okay. The last one is I equal to So from here, you have a C will equal to A, B, C, C. So the C will equal to AB. So we know that these are the A alliance with the BC, B alliance with AC, C alliance with AB. So when you're estimating the effect of the A, actually you are estimating the effect of the A plus the BC. It's not from the A because you only run one half. So these are the information you will lost. Okay, so of course our structure here we can be use a I equal to ABC. We also can be use a negative sign one. Okay, therefore I say that I equal to ABC is called the principal fraction. The other one half is a I equal to negative ABC, alternate or complementary fraction. Okay, so you want to run any of the fraction, do you want to run the principal fraction is also can, as long as you run one half of that. Okay, so this one is the idea of the fractional. Okay, so we still not go through any example yet. Okay, I will go through this thing first. Then if you want to run the one half of here, if you want to define as a complementary, the fraction. So I give you the example also. If the I will equal negative ABC. If I is equal to negative ABC, okay, you are using the negative side. So the alliance will be equal to, of course, you show you here, you just I will equal to negative ABC. So from here, you get the A will equal to the negative BC. Right hand side, the A, you get the A equal to negative BC. Okay. Similarly, if you have a I is equal to negative ABC, so your B will equal to negative AC. Then the third one was C is equal to negative AB. Okay, so you have a negative sign only, complementary fraction. So means that if you want to write in the just now the L, so we have a L here, A here, instead of using the LA prime to represent the complementary, will be equal to the A minus by BC. Just now you have a plus, now you have a minus. Okay. Similarly, for this one is a L for the B complement will equal to the B minus by the AC. The complement of the C prime will be equal to C minus by AB. Okay. So instead of writing the L, you have the square bracket here. Prime will equal to A minus by BC. Okay, so the complement step is just inform you that you are running the other side of the negative, or they are complement of the positive side here. Okay, so this one is where you have a I is equal to the ABC, another one is I equal to negative ABC. Okay, the following one, after you know about the fraction, about what is called the generator, what is called the defining reaction, and then you also will know aliases. Then we proceed with the following one is called the restoration. Okay, restoration here, I will explain you in detail what is meaning restoration for each one. Okay, so just now
The minus sign means that it comes from A and BC as well. Is it just like the plus sign?
yes, they also come from the A and the BC. Because they also come from here. You cannot say that this one is come from the A direction. These two components. Only you run the negative signs, the negatives part of the treatment combination.
Oh, okay.
Okay.
So the sign will be reversed, is it in their when we count the effect, like A and BC, the sign will be different, is it?
The
Will be
sign will
opposite.
different. Yeah, the sign will different because we need this sign later on when we combine the complement and the principal. You can see that the sign will be very important.
Oh, okay.
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 So this one is a complement set. Therefore, I have another sign. Later on, we total out, you can see that the sign will important. We cannot write the plus sign here. Okay. So we proceed with the following one is about the restoration. Just now, I have shown it to you that in this example, we only run is suppose we have a 2 power of 3 design. We only run the fraction. We only run is a 2 power of 3 minus 1 design. Okay, we only run the 2 power of 3 minus 1 design. Means that we only run fraction. Therefore, we have a 2 power of 3 minus 1 design. And then this one is called the restoration tree. I will explain to you why it's a restoration tree later, because this restoration tree will be related to the generator here. So for the time being, we have a restoration tree is because we have a tree here, the 3-factor iteration. So we call as a restoration tree here. Okay, so for time being, I will let you know this one is because I'm using the 3-factor iteration, but may not be every time the 3-factor iteration then is restoration tree. Okay, I will let you know in detail about the definition later. That one will related to the information out here about the alliance structure. So we denoted our design here as a restoration tree. The 3 minus 1 is means that you only run 1/2 of the treatment combination. Okay. Then you defining reaction can be I equal to ABC or I equal to negative ABC. So you can be run any one of them. Okay. So here I will let you know about what is a restoration number 3 here. Okay, but I will give you detail about the restoration. You have a different restoration in the following parts. In this design, they call restoration tree is because the main effect are alliance with the 2-factor iteration. Okay, what they mean by the main effect are alliance with the 2-factor iteration is means that we need to go back to their alliance structure here. The alliance structure here, you can see that the factor A and the factor BC were together. When you estimate the complement of the factor A, so it's actually you are estimating the A together with the BC. So therefore, the A factor you cannot differentiate with where they come from. They actually the both of them. So this one is they have a gather together. So therefore, they call as a main effect are alias with the two-factor iteration. You have main effect here with the two-factor iteration, then this one is called the restoration tree. Okay, so they were related to the also about the defining relation as well. Okay, but if they related to here, then it's called the restoration of the tree here. Okay. So we continue with the following one. Just now you have a I equal to ABC. You have another side is I equal to negative ABC. Because we only run first one or the second one. Okay. How about if we run all? So you can see if you may run the second half. Okay. So suppose after the run one of the 1/2 fractions of the 2 power k design, the other one was also run. So if you run all, means that you get the all information. Okay, so I will show you the diagram how we want to say this one. Obtain the D-aliases estimates of all the effects by analyzing the all 8 runs as a full 2 power 3 design in a block, in the 2 blocks. So just now, if you still remember, we only run the first half of them. Okay, 1/2 of them, only one of them. So we can regroup them as a, let's say, for example, the idea of the confounding is a block 1. You run the block 2. Okay, my block 1 is I use a ABC as a confounding. The idea of here, because I group all the plus together, so we can use a confounding idea, all the positive together, all the negative together. So the block 1 is consists of this treatment combination. Block 2 is another treatment combination. So if I use a confounding idea, so the block 1 consists of the A, B, C, and the A, B, C. If I run only the 1/2 of them, then this one is a positive sign. I use a positive sign. For the another block, I have a A, B, A, C, B, C, and the 1. Okay, this one is a negative sign. So just now we only run the first 1/2 or the second 1/2. So the idea was similar to what before the confounding, where those of the positive sign were in the same block. The second one will be here. So you do in this one, also you can see that it's just a ABC will be confounded with the block. Okay, if you do it in this way, then you do the confounding in the blocks. Okay, so now this one is the idea I want to relate it to the confounding, but now and then we run also another 1/2. So I just copy down just what we have before. Okay, let me see. Okay, the prime here I don't want to put it here. I will put it outside. Okay, so that they will consistent with my here. I just put it here outside here. Otherwise, become here. It's just an effect. It's a complement. So therefore, I put it outside here. The prime, I will put it outside here. Okay. So you observe it. If you just now you get the A will equal to A plus BC. You do the B is equal to the B plus the AC. You do the C, you will get is a C plus AB. This one I run the first half. If I run another half, right? Okay, complement of this thing is the negative one. I will have the A by BC. I run this one, another half of them, I will get is a B. I get the C prime. I will get is a C minus by AB. Okay, so this one you run either the first half or the second half. So if you take the average value of these two, what happens? Okay. So if you consider the average value of these two, If you take the average value, if you run the first half and run the both of the half, you will get your average value will be A plus BC. Then they will go back to the factor A back. Okay. So in our fractional, if we only run the first one or the second one, we only can estimate the effect from the A and the BC together, or from the A and the BC together. But if we run completely the full set of the three combination, if we return it out, we take the average value of these two, you will get completely, you will get your effect of the A. For the B, if you run the full set, then you take the average, you really is estimate the factor B. If you do the average of here, you get your factor of the C. Okay, this one is why we write the negative there, so that you take the average, you will get your go back to the same sign of the A here. Okay, but in this chapter, we only want to run one half of them. Means that half of them, the other half we don't plan to run. If you run both of them, this one will go back to the previous chapter number 6. You run the general factorial design or 2 power k factorial design. You run all the treatment combination. Okay. This one is I explained to you about the here. Okay. Then the following one will be just now I mentioned to you the restoration. So what is meaning by the restoration? Restoration of the R if no P factor is alias with the another effect containing the less than R minus P factors. So what is meaning of this thing? You can see here the restoration of the R, where we have a restoration 3, restoration 4, and restoration 5. Okay, so these are the 3 important ones. Okay. So under the restoration tree, what happened? Just now you have seen the example of the restoration tree. Under the restoration tree, it means that they are the design in which the no main effect are alias with any no main effects. Okay, so this one is means that the no main effect alias with the no main effect, but the main effect will alias with other with 2 factor iteration. And some of the 2 factor iteration may alias with each other. I give you the example. This one, the first one, they say no. It means that after you calculate the A, okay, you will cannot because we put it just now we put the notation as if we put the square here, we will get the A plus something. Okay, A plus this thing. So if they say that the no main effect will allow you will never get the A plus a C. You don't have this case. In this case, it means that main effect alias with main effect. You never will this thing. This one is called the restoration tree. No main effect will alias with any main effect. You never will get this case, but you can be possible to get it. Let's say the A will be equal to the A plus BC is possible. Where here mentioned it, main effect are alias with other 2 factor iteration. This one is just now you have seen it. And some of the 2 factor iteration may alias with each other. Means that if I'm looking at the BC, they may be equal to BC plus the DE. They may possible to get the 2 factor, and the 2 factor will be alias to each other when you have a higher order of the factors. Okay, so these are the 3 possibles. These are the alias structure of the here. If they fulfill for this thing, then they call as a restoration number 3. Okay, they are called restoration. Of course, if you have a higher order iteration, higher order factors. Okay, so this one is called restoration number 3. For the following one will be restoration number 4. No main effect will alias with any main effect or 2 factor iteration. So you never will have this case. This case you never have, or one you also never have. Okay, these two cases, main effect here or with any of the two iteration. So they don't, you never will see the alliance structure if this one. If they have this type of the alliance structure, then they are not the restoration form. But the two factors are alliance with each other. Means that it's possible that you get the B will equal to AB plus the CD is possible. So this one, if you have this thing, then this one is called the alliance structure. Okay, so this one is for the restoration for the number 4. Okay, finally, you have a last restoration is a 5. That the design is no main effect or the two factor are alliance with any main effect or any two of the two iteration. But the two factor iteration are alliance with the 3 factors. Okay, so means that the main effect is never alliance with the any main effect or 2 factor, and then the 2 factor also never iterate with the 2 factor itself. Okay, but the 2 factor can be alliance with the 3 factor iteration. Okay, so the restoration, the higher is a better, in the sense of the better, it means that you can be give out a certain higher order iteration. Because if you still remember before that, I always will tell you, if you can assume that those of the higher order iteration is not significant, then we can be move it to the sum of square for the error if you replicate is 1. So the similar idea for the fractional design also the same. If you can assume the high order iteration will equal to 0, it's not important. Then that higher order iteration will equal to 0. Okay, so you can assume that they're equal to 0. If they're not equal to 0, then you're really estimating the effect from their main effect. I give you the example here. Let's say the BC is not important. The BC is not important. That means that the BC will equal to 0. So when you calculate the effect from the fractional, you are actually calculating the A. Okay, but of course the restoration 4 will never this case. The restoration 3, they will happen this case. If the BC is not important, therefore I can assume that the 2 factor iteration is equal to 0. So if this part is equal to 0, you calculating using the contrast from the fractional is actually calculating the factor of the A, where you assume that BC is not the important factor. Okay, so this one will tell you that if you have a higher order restoration, then you have much more information. So for example of here, okay, if you can see that the main effect, no main effect will iterate main effect of 2 factor. So we don't have the such case, they were together. Okay, then the 2 factor iteration are alliance with the 3 factors only. So if we can assume that the 2 factor iteration is not 3 factor iteration onward is not significant, and when you calculate the effect itself, so you are calculating the effect of the 2 factor iteration. Okay, so this one will tell you you have a different restoration will give you different information. Okay, so for the following one, I think that I will continue this one next week with the examples here. Okay, this one will be here. Okay, I will go through this one more page first. Okay, I finish out this part. Then after that, we'll go through the example for the next week. I will show you to you why they run the 1/2 and then how we want to make the conclusion from the 1/2 here. Okay, so I finish out this part first. A 1/2 fraction of the 2 power k design of the highest restoration may be constructed by writing down the basic design consisting of the run for the full 2 power of k factorial design, and then adding the k factor by identifying the plus minus sign. Actually, this thing is related to here. Okay, so related to this table here. Okay, so this one, I think that both of them together, I will show it to you how you want to get out your restoration, and then how do you want to get out which are the treatment combination you are going to run. Okay, you have one half of them. So which one? Okay, so I believe that to. Okay, I stop until this part here. Okay, I will stop until this part. Then we continue with the tutorial first. Okay, so for the fractional one, I have 2 parts of the notes. This one is only the first part. We still have another parts of the notes. Okay, so I'll upload this thing first in the spectrum later on. Take out the here. Okay, in this tutorial where I give you the consist of the quite number of the question, but the skill will be just a repeated skill. Okay, so in the 2 power of k design, then they try to identify the important factors. Okay, basically the whole thing, the tutorial question is will be repeated. Okay. In the tutorial 3, you have 6.2. You have a following one will be the 6.2. After that, you have a 6.5 and so on. Okay. So the important thing in the 2 power of k, the important thing in the 2 power of the important thing 2 power of k design, what you need to learn about the 2 power of k design is means that you need to able to calculate the effects. Okay. You need to calculate the effect of them. Okay, well, based on the contrast divided by n times 2 power of k minus 1. And then also you need to be able to get the sum of square will equal to the contrast of the square out divided by n times 2 power of k. So these are the things you need to know only. Okay. So after that, of course, you need to calculate the confidence interval for the effect to check whether significant or no significant. You can use here, or you can form the ANOVA table to do that. Okay. So hopefully we have go through the 3 chapters. when you look at what is meaning by 1 here, you understand that is the 1 here is stand for all at the low level. If you put the A here, it means that only the A at the high level, the rest of. And then we list down in the following form. This one is called the standard order, where you can see that I will put the negative plus, then 2 negative, 2 plus, and then 4 negative, 4 plus. So if you write in the following order, it's a standard order, you're writing out your treatment combination. So the 1 here, in the notation of 1 here, is stand for the total of all. Okay, so in this example here, we have a n is equal to 3. Okay, you repeat for the 3 times of them. For each one, you repeat it. 1 here, if people write the 1 here, because you 1 here is just a total. So you have 22 plus 31 plus 25. So the 1 here is actually you have a value 78. You total out all these things is same for the total. The A here is means that the total for all. 32, 43 plus 29. You get 104. Okay, and so on. This one is stand for the total. Okay. So from the here, the first one is ask you to estimate the effect. So of course, from the effect of the here, you want to calculate the effect of the A. Then of course, you just base on the sign here with the here. Then divided by n times 2 power k minus 1. Then you can get your effect of the A. So altogether in this question, you have a manual effect. You have a A, you have B, you have C, AB, AC, and the ABC. So all these effects you need to calculate out. So from the effect itself, if they no effect at all, then the answer will be 0. So if they have a slightly larger than the 0, then there's small effects. But from here, out of here relatively, then we just check which one have a high effect only. Okay, so how to calculate the effect for A will be equal to the first one is a negative 78 plus the 104 plus and so on. Okay, you use a minus 178 plus 104 plus minus the rest of them divided by n. The n is equal to 3 times 2 power of 2 is equal to 4. So these are the things. Then you can calculate the effect for each one. Okay, this one is useful for the 2 power of the k factor. So once you get your effects, we can put in the normal probability plot here, then to study which are the important, which are the effects, and then the important factors. Okay, so those are the important factors. It means that they're far away from the straight line here. Of course, you cannot use the ordinary graph paper to draw your normal probability plot because the scale will be different. You need to use a normal probability plot, or you use computer software to help you to draw it. Then we can identify out the 3 factors here. So in the exam, I will never ask you to draw the normal probability plot here. Unless you do the assignment, then you can go for the normal probability plot. Okay, you can use a software to draw the normal probability plot. But in the class, I will not ask you. I will provide you the normal probability plot. Okay, then from there you will just identify. Even though here I have mentioned to you, those of the point or far away from the line here is considered important. So I also no need to supply you the normal probability plot. I can tell you the statement say that from the normal probability plot, we can identify which are the factor is far away from the straight line. That's all. Okay. So question number 1 here, the one here, based on the plot here, we can identified. These are the 3 important factors here. Okay, for the B, C, and the AC are the important factors. So far, we not deal with any modeling yet. We don't fit the model yet. So therefore, we just stick it to we have a B, C, and AC are the important factors. Because I think some of you, one student will ask me, they can be have a many factor, because if your AC iteration is significant, how about the A? Is it the A also we need to consider? Because that one is deal with the modeling. Okay, modeling, you can be put in the factor A, even though not significant, you also can be possible to put in, because the AC is a, okay, then you want to put in also can, it's possible. But that one is just a tentative model, but I still not go through that part yet. Okay, so for the time being, we just draw out the calculate the effects. Then from the effect, we just identify those are the important factors. Okay, so this one will be help you on the first part and this part here. And then based on the here, the analysis of variance to conform your answer in the part A. So you want to run the analysis of variance also to confirm that whether you're using these techniques, you will get BC and the AC are important. So therefore, if you want to do for the using the analysis version, of course, we need to get the sum of square for the A, sum of square for the B, and so on, until sum of square for the ABC. Okay, then finally, we can calculate the sum of square for error, because sum of square for error here will help you to form. Okay, so this one are the, and then you get your F, the sum of square for error. Okay, of course, this output is get from the textbook, the design expert output. So their output may be different from the what you use other software. Okay, they're using the design expert for this textbook, the software, but I do not have this software. Okay, but the result will be same, because we just need to know whether we calculate is correctly or not. Okay, and then from the output here, I think that at least I give you so many examples. At least one of them you need to do the calculation so that you're familiar with how to get the sum of square, how to get the effects. Okay, so from here, we can be observe that. Sorry, this one is overall model. Overall model was significant. Okay, but we can be observed that the factor B will be, the p-value is quite small here. The second one will be AC. Okay, we have these two, and then some more. We have a C here. C here also 0.0077. So these are the three important factors. This result will be consistent with the normal theory report, where you have a B, C, and AC are important. Okay. So once we have these three factors are important, the rest of them are not important, then we can be reduce the model. Okay, as I just now mentioned to you that we can be maintain that the factor A to maintain the hierarchy. We will maintain the factor A in the model itself. Okay, so this thing is deal with the modeling, but we objective, when is it we want to maintain or not maintain. Okay, so that when we go through the modeling parts, I need to give you the criteria. Otherwise, some of you may say that the factor A is not important, so I already remove it. I only form the model using the B, C, and AC. That's all. Okay, but you still can be put it inside. So that one I will do during the modeling parts. I will inform you all, but we never have a one final. Which one is a good one. Of course, we can be based on the different criteria to judge that whether we need to include the A or no need to include the A. Okay. So of course, in this style of the design, we need to checking the residues to make sure that the models you obtain will be have a whether the models or the factors here they residue they fulfill that. Okay. So if you observe it, these three of the plots here or the two plots here do not have any unusual pattern. So we will get the accept the plot here. Okay. Of course, you do not have a perfect because here have a certain shape here. But this one is here. Even though they have a certain of here, but in general, we still can be accept it. Okay. normally the constant variant, we still can accept it. Okay. And then over here, this one is also one of the factorial design. The AC, the were important, means that you want to interpret for the factor A and factor C, you need to take note about the AC iteration. But the factor B alone is don't have any iteration. Therefore, we can explain the factor B alone. But when we explain the A and C, we need to take care about the C here. Okay. So in this example, because they want to know the effect of they interested to know the effect of these three on the machine tools here. Okay, so the factor is here. So over here, based on the analysis of the main effect and iteration part, what level of the okay, so of course the B alone do not have any iteration. So we set the height level, here's the life here. So if you want to have a height value, then we choose the B effect of the B, which one have a highest. But about the iteration AC was significant, then we need to consider which combination of the C and the A will give you the highest life. Okay. So this one is a plot here. The plot here, if you plot the mean of this one is a factor B. If you plot the mean of here at here, the mean of the here, because only two level, at the lower level, at the high level. So for the factor B, you choose the highest one. So this one is choose the height, the plus sign. Okay, the height, you have a low level and a high level. So it's choose the high level here. So for the iteration is 2. So this one is the red color is for the C high level, and then the negative is for the low level. For C negative is a low level of here. So this one is a cutting. The cutting speed here is referred to the factor A. Okay. So this one is for the factor of C here. So if you want to have a high order, the life is a height. So we should be consider of the here. One is the iteration here. Then if you want to get the height, then this one should be the height here. Then C at the red color is C at the positive side. Okay. The C at the positive. The A is at the negative level. Okay, so this one is the B at the positive, the A at the negative, and then C at the positive. So these are the combination of the level you should consider if you want to have increase your life. If you want to have a life, then the B should be chosen at the negative. Then the A should be chosen at the lowest, and then the C is choose the black color one is negative also. So the A is negative, B is a negative, C also negative. So it depends on your objective of your study. You want to have a highest or lowest. Okay. So this one is where you discuss on the plot. So actually the explanation for this one was similar to the factorial design, because 2 power of k is still the same thing as a factorial design. After that, you have a question of here. The question of here is I have taught you about how to construct the confidence interval for the effects. Okay, the confidence interval for effects will be based on the SE for the effects. Okay, so you can construct the confidence interval for the effects using the effects plus minus the effect plus minus the t distribution multiplied by the sum or square the SE for the effects here. Okay, so this one is you can recall back what you have before. Okay, the calculation of the effects here. Okay, The sum of square for the standard error of the effect was given by here, where the S square here is actually your MSE. You use the MSE here to estimate your here the sum of square of here. Okay, and then this one is a sum or standard error of the effect will be calculation of here, where the S square is a MSE. Then after that, you can calculate which factor will be significant. So again, we have the third techniques of here. Also, the B and the C and AC are significant. So based on the first question just now, you can be plot the normal probability plot to identify the important factors. Okay, you can be do another one will be based on the ANOVA analysis of variance table. You also can be test whether which one is significant or not. But of course, from sometimes the point is also very close to the the line here. Then you cannot see it clearly which are the important figure one, unless they very far from this line. Then you can be say which factor are important. If they are very close or sometimes it's in the gray area, so you do not know whether that factor is important or not. So you need to carry out the analysis of variance to checking which factor are the important. Okay, but if this one is you want to use ANOVA, you must provide that you can find the error. If you do not find error, you cannot find the error. Okay, the sum of square for error, then you cannot be form the ANOVA table. So it means that you depends on here. But in this example, so you can use these techniques, or you can use this ANOVA table, okay, to so that you have a SSE, or you can be use the effects of here. You want to calculate using the effect here, you still need to calculate the sum the MSE. So without the MSE, then you cannot calculate the confidence interval here. Okay, so you can have a flexibility there to do any of the techniques. Okay. So this one is what you have in the chapter number 6. Okay, so I believe that the following one will be the similar one. Okay, so I will expect you all at least you try 1 or 2 examples, so that you are familiar with those of the calculation to get the effects and the sum of square. Okay, so I check it out the question there. Okay, and this example will be another example. Okay, if you think that the calculation will be too long, where they involve many factors, then you can try the first example only. Okay, the second example here, if you have a software, you can try it out. Okay. What you have, this one will be the similar one. Sometime in the exam, I will directly give you this thing. I don't ask you to give you the raw, do the calculation. No, I will directly give you the effects, or I ask you to fill in the blank of the effect only. At least we need to train you whether you know this effect is how they calculate out. Okay, so in this example, I give you all the effects. Then of course, if you want to know which are the important effects, we can from the here relatively we can see that those of them near the 0 is look like it's not really significant, but they have a height. One is should be a 70. Okay, negative 67. Then you have AB is quite high. Then you have BC is around 20. Then this one is around 18. Okay, these are a few of them is considered as a high relative to the rest of them. Okay, but whether it's a significant or not significant, then we need to test the ANOVA. Okay, but because of this one is using the single replicate, so therefore I want to form the ANOVA table, also unable to do that. Okay, but if you use a Minitab here or any software, they can plotting for you, and then they can identify that these are really the important factors. Okay, even though just now I circle here negative 18, 20.78, they are relatively large as compared to the rest of them. But in the normal probability plot here suggested by Daniel using this type of techniques, we can know which are the important. So even though these are the very large, but we do not know whether when you test the hypothesis is significant or not. So it's only A, B, and A, B will be important. These are the thing is not important at all. Okay. So this one is a question number 6.19. Okay, the 6.19. After that, you have this one also is quite a lot. So therefore, this thing is you study about the 5 factors one. So this thing I do not think that I give you the raw data of the all of them, but if you have a software, you can do it. Otherwise, you not necessary. You need to do it manually. Okay. Let me see what you. Okay. I think basically all of them they are quite similar. Okay. These are the thing is a plus minus sign here. Okay. These are the similar work. Okay. Any of you have a question? Okay. I think this part the last question I give it to you this one is a page number 13 here. About this question I given it to you here because sometimes you may need the transformation where your what the assumption of the residue is not fulfilled. So you can see from the answer here, the 6.33. If I do the analysis of the 2 power of 4 factorial design, I will get the important factor is A, B, and AB using the drawing the normal probability plot. It's A, B, and AB. But when we checking the residue, they have a problem with the residue. The analysis of variance also show that it's important. But when we checking the residue, they are non-constant variant. If you observe the here, you have a non-constant. Then some more also, your residue of here will be here and here. So the normality assumption they are not fulfilled. The constant variant also they may not be fulfilled. So therefore, we need to try for the different transformation. Okay. Accept these results. If you just accept this result, you just accept the A, B, and AB as your model. Then when you formulate your model, you are using the A, B, and AB will be wrong. Okay, because they do not fulfill the assumption. They do not fulfill assumption. Therefore, when you're choosing the model, it may not be accurate. Okay. So because of here, we can be transformed it. So normally the log will be very useful for the transform the values. Okay, the log transformation. Of course, this one is not only one of the transformation. You can use other transformation. Okay. So after they perform for the log transformation, you can see the normal probability. We only identify 2. Okay, compared to the just now, the 3. They only have a 2 are the important factor. So based on the transform of the data, we just double check of the residue of the model. Okay, of course, the ANOVA table here, you already identified these are the 2 important ones. Then we checking their residue. You can see that it's not as obvious as just now. Now is even though you have a certain shape, but in general it's still quite consistent. We still accept it. This one is they quite far close to the line of the normal body plot. Compared to just now, you have a different shape. Okay, so this one will be help you to let you know that how good is what your model assumption. Okay, not only in this course, we have other courses. When we do the modeling, we also need to test the residue. Okay, we need to test whether this type of residue will fulfill the model what we're fitting or not. If they still not fulfill the model's assumption, I believe that the model may not be useful. Okay, even though you get the results, you just simply go to interpret the result. similar to this thing. I can say a lot of they just get the result. Once they get the result of here, they use the result, they directly put in the data. They put in the software, they analyze, they come out this result, they just accept this result. But they don't care about whether the residue they have fulfilled or not. But in this example, if you can observe it, if the assumption what you set for model, then you may lead you to the wrong conclusion or the different conclusion, where you have a A, B, and AB. But after you transform where they fulfill, you only left is a two main effects. Okay. So this one is I want to go through with you all for the class for this week. So bear in mind that the next week we have the test. So the test you can be use a software, or you want to use Excel, you can use Excel to do that. Okay, because sometimes you want to calculate the sum of you want to use a software to calculate. Also, I don't block you from the R also can, or you want to use a manual calculation also can. I can say that definitely you have enough time. Okay. Any more questions regarding the test? No, huh? Okay, if you have any question, you text me. Yeah, anything. Hello.
I have a question just on the schedule.
Which one?
When is the
schedule for what?
Yeah, when is the group assignment?
Oh, group assignment. After I teach you more what examples, more what different. Give you the group assignment. The group assignment, I can tell you the group assignment is I ask you to go to find the real application from the journals papers. So I do not ask you to go to collect the data, because we can't collect the data. So I want to let you know there are real examples of here, because sometimes when I go through the tutorial question with you all, the tutorial question, some of the question, the data is a real data. Some of them, they don't give you the source. Maybe the data is the artificial data. Okay, but in the assignment tab, I will ask you to go to survey it out. So therefore, it's just like the searching the material only. Then I need to tell you have a more design first before you can go to survey. So the assignment two, we will I can give you the due date is until end of semester is fine. Okay, so I think that so far is no need. I don't finish a certain design yet, so I no need to ask you to do for the assignment yet. Okay.
Okay, thank you.
Yeah, I will inform.